A person drives a car, total mass 2,000 kilograms at a speed of 10 around a curve with a radius of 50. Calculate the magnitude of the friction force that is exerted on the car to keep it moving through its circular path. So the car is traveling in this like circular path, and there's a radius of 50 meters, and when we run into it, it's going 10 meters a second, right? So this is a bird's eye view. We're just like looking straight down on the car.
Okay.
If we were looking from the like back of the car where you could see like headlights or whatever,
Okay.
it would have some sort of normal force, a weight force, and then the thing keeping it going in a circle at this position would have to be friction. There's got to be some sort of like friction.
Wait, keeping it
Going in a circle, right? Like if the car were trying to do this on ice, it wouldn't be able to keep a circle. So
gotcha. Okay, that makes sense.
Right. So the friction between the tires and the rotor are what keeps it going in a circle. So they want to know the friction force exerted to keep the car to keep it moving through in its circular path. So if I sum the forces in the center seeking direction, like that way, where things that point toward the middle are positive and things that point away from the middle are negative, then the only thing that points toward the middle is this friction thing. That's equal to mass times the acceleration in the center seeking direction. So then I get, yeah, and centripetal acceleration is v squared over r. So then you just plug in all the stuff. I should have done it up here. I'll do that for the other ones. That's 2,000 to...
R. That's the centripetal acceleration?
Yeah.
Oh, okay, so that's easy to solve for.
Over 50. And that's equal to some number. $4,000 newtons. Okay. Number 10, a person pushes a 20 kilogram object along a horizontal surface with a surface force of 500 newtons in a direction that's 60 degrees below the horizontal for a time of 10 seconds, moving at a distance of 10 meters. What is the average power delivered by the person? Okay, so here's the object, and they're delivering a force of 500 newtons. And we'd have to break this up into its components, where this is 60 degrees. So this would be like 500 sine 60, and this would be 500 cosine 60.
Right.
500 cosine 60 is 250. Right. So then, do you know this equation, power equals force times velocity?
Yeah.
It just comes from work equals force times distance, but like you divide by time on both sides.
Work equals force times distance, right, which is the same as power.
Right. Force times distance, then you divide that by time, divide that by time. This is this is power.
Oh, and then distance over time is.
Right, yeah.
Okay.
Okay, so but it's the force that's like causing the work, which is only the horizontal portion.
So 250 newtons.
Yeah, so 250 newtons times the velocity at which the thing is going. It said it moves 10 meters over the course of 10 seconds, right? 10 meters, 10 seconds. So that's 250 watts. Easy enough. A popular roller coaster ride immediately launches riders in a cart, total mass, from rest very quickly up to a high rate of speed. We can model the roller coaster like a spring system, which has a spring constant of 1500 newtons per meter and is initially compressed over a distance of 60 meters. How much potential energy is stored in the system? So the spring potential of a thing is 1/2 kx squared. So this is just a long way of like wondering if you know what the equation is. Yeah. So you put in 1500 newtons per meter, and then the thing gets compressed 60 meters. So this is 1500 times 60 squared. Did you switch calculators on me?
No.
You sure?
I checked my. I use this for my stats class. I have all my stats in my.
Oh.
Yours is clear.
I don't even know how to read this. What is this?
2 million?
2.7 million?
Yeah. I don't know how to read. Potential energy of the spring. And that's when it's coiled, right?
Mm-hmm. Yeah.